Good morning or afternoon, whichever is your time. Today we have a slightly different situation because we have a split class. So we'll talk about some things that both in-person and remote students will do, and some that we'll be doing only in person. The first is the introduction, which is a metric mood video, which should play for you automatically if you're in the classroom. But if you're at home, please be sure to run this video. It is set to music, but it has very important information about the metric system, and it's important that everyone should watch this. Okay, so first we'll talk about what the metric system is about and how we use it. So let's watch this video, which is actually done quite well.
Hi everyone, I wanted to give you a quick little crash course on how to use a meter stick when you're measuring and converting using meters and decimeters and centimeters and millimeters and things like that. So this right here on the table is 1 meter. It's a little bit longer than 3 feet. It's a little bit over 39 inches. And if we look at the meter stick, we need to make sure that we're on the proper side. So we want to make sure that we're on the side that goes all the way up to 100. We want to make sure that we're not on the side that ends at 39. So that's the first thing. Make sure that you're on the side of the meter stick that goes all the way up to 100. And along the meter stick, you'll see right here, we have 1 centimeter, 2 centimeters, 3 centimeters, 4, and so on. Now, every 10 centimeters is a decimeter. That's DM, the abbreviation DM. So that's 1 decimeter, and then 2 decimeters, 3 decimeters, 4 decimeters, and so on. And each one of these, like I said earlier, is a centimeter. 1, 2, 3, 4, 5. And each one of these tiny little guys, let's see if I can get a good angle here just a second. Each one of these tiny little dashes here is a millimeter. So there's 10 millimeters in a centimeter, and then there's 10 centimeters in a decimeter, and there's 10 decimeters in an entire meter. So let's say we want to measure this table here. So we start down here, and we have our meter stick set up, and so we start there and we go, okay, there's 1 meter, and then we move the other end of the meter stick to where this end ended. So we want to make a note that that's where it stopped. And we put our meter stick right there. And we go, okay, so it's 1 meter and plus 36 centimeters. And if we get in even closer, we see that it's about, about 6 millimeters. So it would be 1.366 meters. 1 meter, 3 decimeters, 6 centimeters, 6 millimeters. So there's a whole lot of ways you can measure it using the meter stick and the metric system. But that's how you would do it, is by using your meter stick and then zooming in closer and closer and closer as you get to the end of your measurement. If you have any questions, let me know. Take care.
Okay, that was a lot of information, but please remember the very important point that this teacher made. Make sure you are on the correct side of the meter stick. We've had many students have to redo all of their measurements because they were on the wrong side. So look carefully. It has to be the side with all the small little marks, and it has to go up to 100. Otherwise, you're on the wrong side. Okay, so then we need to know, well, what are we actually doing with metric system? What is all that decimeter and centimeter stuff? So let's learn a little bit about that.
The entire world uses the metric system for measurements. The entire world, except for Liberia, Myanmar, and the United States of America. In the USA, we use English units like inches, feet, pounds, quarts, and gallons, which is fine, except for that you have to memorize or look up the strange conversions to get from one unit to another. To avoid confusion, scientists around the world have adopted the metric system, which is based on multiples of 10. The base unit for measuring length is the meter, the base unit for measuring mass is the gram, and the base unit for volume is the liter. In order to measure anything smaller or larger than these base units, you can add a prefix that's a multiple of 10. There are 6 prefixes that go smaller and larger than the base unit that I'll show you. There are lots more than this, but these are the ones that you're most likely to come in contact with. In the middle are the base units with a value of 1, like 1 meter, 1 liter, or 1 gram. On the right will be smaller values, and to the left will be larger values. If we want to use a unit that's 10 times smaller than the base value because a meter, liter, or gram are too big, we can go down to the 1/10 and use the prefix deci, which is abbreviated with the letter D. Then you can have a decimeter, deciliter, or decigram. 1/100th is centi, with the letter C for centimeter, centiliter, and centigram. And 1/1000th is milli, letter M, for millimeter, milliliter, and milligram. We can go to larger units when we're measuring larger things too. 10 times larger is deca, and is abbreviated DA to distinguish it from deci. So you can have decameters, decaliters, and decagrams. 100 times larger than 1 unit is hecto, letter H, for hectometer, hectoliter, and hectogram. And 1,000 times larger than the base unit is kilo, or K, for kilometer, kiloliter, and kilogram. I use a mnemonic to remember the order from kilo to milli, and it's King Henry died unexpectedly drinking chocolate milk. But you can make up your own to help you remember their order. Let's see how to use this information. You can take any prefix and attach it to any metric base unit. If you chose kilo and gram, you'd have a kilogram with the symbol kg. Or you could choose deca and meter and get a decameter with the symbol DAM. Or you could choose milli and liter and get milliliter with the symbol M with a capital L. You could make any combination you need. There's one other really great thing about the metric system, and that's how easy it is to convert from one type of measurement to another. When you write the units out in order of largest to smallest, the conversions can be very easy. Remember that the smaller values are on the right and the larger values are on the left. Let's say you had 100 milligrams and you wanted to know how many grams this was. First, you look at the prefix. It's milli. So we're going to start from milli and move to the left until we get to grams. We have to move it 1, 2, 3 times. This means we need to move the decimal point 3 places to the left. Start with deca and move it to the right until you get to milli. 1, 2, 3, 4 times. So move the decimal 1, 2, 3, 4 places to the right, and you get 25,000 milliliters. Let's try 2 more. Practice using your mnemonic to write out the first letters of the prefixes. Let's convert 4.26 centimeters to kilometers. Start at centi and move 1, 2, 3, 4, 5 places to the left. Move the decimal the same direction, the same number of times, and you get 0.0000426 kilometers. It's good to do a logic check and see if your answer makes sense. 4.26 centimeters is a very small measurement already, so it makes sense that it would be an extremely small fraction of a kilometer. Let's do one last conversion. 0.0024 hectoliters to milliliters. Start at hecto and go 1, 2, 3, 4, 5 places to the right and move the decimal the same number of spaces. And you get 240 milliliters, which is probably a better unit for the smaller volume anyway. Thank you for watching this episode of Teacher's Pet. Don't forget to like and subscribe and follow me on Twitter at SciencePet.
So that was a lot of converting. I will post that grid on Echo so that we can use it when we're measuring today, when we're changing from one set of units to another. But that's a very good explanation. I'll also post the links for these 2 videos in case you want to refer back to them at a later date to practice your measuring. Okay, now independent assignment, both for in-person and remote students, is notes on the metric system. Okay, there's a presentation that you'll look at. It's a series of slides, basically a PowerPoint, and you'll put 15 notes in the Dropbox. Please note this instruction. Your notes must be numbered. So not little dots, not dashes, not nothing. Separate them and number your notes. Now, when you look at that particular presentation, there are some slides at the end. Kind of looks like it's a question and there's really not a place for you to put an answer. That's okay, but please be sure that you look at it because it's all about picking the right units for the right thing. So let's say you were measuring how much fluid goes into a bottle of pop. Well, you might use liters. What if you were measuring how much water goes into an Olympic-sized swimming pool? Well, that's going to be a lot of liters, so you might use something like kiloliters, which makes more sense. The distance from the classroom door to your desk, you could measure that in meters, but what about the distance from the Earth to the moon? Well, that's going to be a lot of meters, so maybe you want kilometers or kilometers. So just think about what you're measuring and make sure that you are using a unit that makes some kind of sense, okay? Otherwise, it really doesn't work out very well for you. Okay, now, remember to work on your Whippet whenever you have time so we can finish that up. The presentations I've been getting have been awesome, so have fun with it. Now, for students that are in school today, we will be doing a length lab, and that will be done on paper and looks like this. So let's go over what these questions are actually asking. So for one thing, what does each unit represent? That means write the name of it. So this is the abbreviation for a unit. Write out the name of that unit. So you might want to look at the charts or refer back to the notes that you just took on the PowerPoint. Okay, now this question 2 is actually a conversion. So if you have a meter, how many centimeters are in that meter? So you put the number here and so on. Question 3 is about what are we actually looking at? So what's larger, a centimeter or 14 millimeters? Now, you can look at your meter stick to do that, or you can think about what you're doing. So in a centimeter, how many millimeters are there? So is 14 millimeters a little more than a centimeter, or is it less? Same goes for some of the others. How many meters are in a kilometer? And so is this a part of a kilometer or more than a kilometer? So you can figure it out that way. Now here is actual measuring. Here you're going to use your meter stick, and remember, make sure you're on the correct side. That would be the side that goes up to 100, not the side that is inches and goes up to 39 or so. Okay, so make sure you're on the correct side, and you're going to measure this line and write that there, and it's asking for you to put it in centimeters. Now, it might not be an even number. It might not be like 10 centimeters. It might be 9.7 centimeters. So that's the number you'll write here is exactly what you measure. And here it wants you to round to the nearest centimeter. So remember, 1 to 4, you round down. 5 and up, you round up. Okay? Now, here is a rectangle, and it asks you to measure the height, again, nearest millimeter, so round. So the height is this way, and the width is this way. So look at it for a minute. Clearly, the width is going to be a bigger number than the height, so that way you know if you've done it right. Okay, here's a circle. The first question asks you for the radius. Do you remember the radius? It goes from the middle to the circle. Okay, that's a radius, and it'll be the same no matter where you measure it in the circle. So again, nearest millimeter. Make sure you put it in the right units and that you round. Then it's asking for the diameter of the circle, but that's not in millimeters now. That's in centimeters. And the diameter is from here to here. Okay, so measure that using your meter stick in centimeters, always making sure you're on the correct side. And this one is the exact measurement. Here in G, you're going to take that measurement and round it to the nearest whole centimeter. Remember, up to 0.4 goes down, 0.5 and up goes up. Okay, so remember, here's just to remind you. Okay, so nearest should have no decimal points. If you haven't rounded, it'll have a decimal point. Okay, so that's for starters. Now, volume. This is asking for the volume of the box in cubic centimeters. So that tells you that you must measure each measurement in centimeters so that you can multiply them, and then you get cubic centimeters, centimeters to the power of 3, or you can abbreviate that cc. So how are we going to measure that? Well, it's got 3 dimensions, right? This one, let's call this one width, this one, which is height, and this one, which is depth, because it's representing a 3D object, okay, 3-dimensional. So you're going to measure this and this and this, write each answer here in nearest, so rounded centimeters, and then you multiply them. Do not add them. Multiply them, and that'll give you the 3-dimensional volume of the box. Now, length of an unsharpened pencil, including the eraser. So if you can't find an unsharpened pencil, you can just measure the pencil, including the eraser, if it's there, up to where the point would start. Okay, so you just choose what represents to you an unsharpened pencil. You can just ignore the parts that don't fit into that description. Okay, now this is interesting. Your height in centimeters. Okay, so make sure you're looking carefully at the meter stick, figuring that out. And in meters, so meter would be the whole stick. So how are you going to do that? Don't convert from inches or feet. Measure each other. Okay, you can use one stick and move it, or you can use multiple meter sticks. Just make sure you watch out for these units. Here is centimeters, here is meters. So think about which one is going to be the bigger number. Not that the unit is bigger, but the bigger number here. And you can round that. You don't have to use the decimal points. Now, find the distance between the 2 index cards in the hallway in meters. This will be changed a little bit because we usually use some duct tape on the floor, and it might be in the classroom instead of the hallway, but that's still okay. The idea is to measure the distance. Now, here's an interesting one. You need your shoe. You do not have to take your shoe off. We don't need to smell that, okay? But you're going to measure your shoes. What is the length of your shoe to the nearest centimeter? So nearest tells you you're going to round it. So you're not going to have any decimal points in this answer. So just measure from heel to toe. Now, how many shoes would it take to make 1 meter? So that means if you're going to take your shoe and line up a bunch of your shoes in a row, how many shoes will you need to make a meter? You should do this by converting from unit to unit. I do not recommend taking your shoes off and laying them along a meter stick, although I've seen that happen and it's okay, but it's kind of gross. Okay, so that's to make a meter. Well, now here's a problem. Now, how many shoes would it take to make a kilometer? And a kilometer is a unit the size of, kind of a few miles. So you really are not going to do that part. So there you're going to have to do some multiplication to figure out how many of your shoes you need to line up for a kilometer. The next is pennies. We have pennies available in the classroom. And the questions are, how tall is a stack of 10 pennies? So you're going to stack them up, right? Now you're going to have, how tall would a stack of 100 pennies be? remember, in centimeters. So are you going to stack that up? That's going to be kind of up to you. How tall would a stack of 1,000 pennies be in centimeters? I don't know about stacking that up. So you're going to have to figure that out. What's the best way to do this, and how are you going to do it? Now here you're choosing the best metric unit. And this is kind of logic. Just think about it. Do you want to measure your eyelash in kilometers, which is, in the order of miles, or one of the others, millimeters, centimeters, meters, and kilometers? So you decide. Same decision for a flagpole. How about some spaghetti? How about going from Chicago to Peoria? What would be the appropriate unit? And circle the one that you think is the right unit for that particular item. Okay? So in class, students are going to get started with the lab, right? And at home, students, make sure you listen to Metric Mood and do your notes on the metric system, and go back and finish your Whippet, and also anything that you are missing, any black zeros or assignments that you haven't finished. Okay, let's get going.